everyone to my higher secondary channel, that is Advanced Science for Teenagers. I'm Rabeya'S and hopefully you all are well. I also hope that you all will remain with my two channels through my videos where I usually make videos on secondary and higher secondary sciences. However, at the end part of each physics and chemistry video from the channel Advanced Science for Teenagers, I will try to add at least one mathematics with a related discussion of physics and chemistry. But when uploading any video of higher mathematics or biology, I will not add any mathematics in the last part of video because the discussion of higher mathematics is all about mathematics, and in the last part of biology video I will try to add at least one figure with a related discussion of biology. In my today's video I will try to discuss with you some topics from the second chapter of your physics first paper book. As usual, I should start the discussion of first chapter, but I have thought that the topics of second chapter may be more important compared to the first chapter. So, after finishing the discussion of second chapter, I will definitely start the discussion of first chapter, inshallah. So, let's start our today's video. Classes 11-12, Physics first paper, Chapter 2, Vector. Today we will discuss what is scalar quantity and vector quantity. After that, properties and symbols of vector quantity. At first, we will discuss about what is physical quantity. Generally, every day we have to by both magnitude and directions. Physical quantities are categorized as scalar quantity and vector quantity depending on their magnitude and directions. A physical quantity can be expressed as a value, which is the algebraic multiplication of a numerical value and a unit. For example, if I talk to anybody like this, my body mass is 50 kg. Here you all can see I have expressed my body mass as 50 kg. So here 50 is the numerical value of my body mass and kg or kilogram is the unit value of my body mass. So we can say the algebraic multiplication of 50 and kg actually expresses my total body mass. Now we will discuss about two types of physical quantities. These are scalar quantity and vector quantity. What is scalar quantity? A scalar quantity is a measure of quantity. Scalar quantity does not have any directions. It is totally described by magnitude or a numerical value. For example, if I talk to someone like, I have driven 10 kilometers of the road through my car, then here you all can see that I have added only 10 kilometers of the road which I crossed through my car. But I did not add any type of direction like I have driven 10 kilometers to the north of the road through my car, or I have driven 10 kilometers to the east of the road through my car. Hence, 10 kilometers of the road here express the magnitude of the road. So we can say 10 kilometers is actually here a scalar quantity. Besides, a scalar is any number that gives the size or magnitude of a quantity. So, a unit of measure must be attached to the number like meters, kilograms or seconds. In physics, the physical quantities which have only magnitude are known as scalar quantities. Some examples of scalar quantities are mass, density, energy, volume, power, work, pressure, frequency, charge, etc., which can be described only by magnitude but not the direction. Now I will discuss with you some examples of scalar quantities. Here in this slide you all can see the volume of this box is 3 cm and height of this box is 15 cm. The volume and height of this box do not have any direction. They only expressed the magnitude of this box. So we can say it easily, the volume and height of this box are actually the examples of scalar quantities. Again, the area of this box is 45 cm square, which is the multiplication of volume and height of this box. Here we can see the area of this box does not have any type of direction. It only expresses the size of this box. So, again, area of this box is an example of scalar quantity. Second one is about the mass of a cylinder. Here we can see the mass of this cylinder is 12 kg, which refers the amount of the material from which the cylinder is made is 12 kg. Hence, 12 kg refers the amount of the material and does not have any type of direction. So, we can say 12 kg is an scalar quantity. And the final one is about the wavelength of a wave. The wavelength of a wave, which has been shown in this figure, is 3 cm. Here, we do not know any direction of this wave. We only know the length between the two waves. So, the numerical value of the length between the two waves definitely an example of scalar quantity. What is vector quantity? A vector quantity is defined as the physical quantity that has both magnitude as well as directions. In physics, vector quantity is a quantity that is described by magnitude and directions. This quantity is usually represented by an arrow whose direction is the same as that of the quantity. A vector quantity is different from a scalar quantity in terms of direction. Therefore, every scalar quantity is one-dimensional, but vector quantity can be 1, 2 or 3-dimensional. In the case of one-dimensional vector, the change of position or motion of the object along the x-axis is to be considered along the horizontal. For example, I am walking 2 kilometers north from the market. Here, we have to consider 2 kilometers north as an one-dimensional vector because we are counting the quantities along the x-axis. After that, In the case of two-dimensional vectors, the change of position or motion of the object along the x-axis and y-axis are both horizontal and vertical are to be considered. For example, the change of the position of a lizard on the wall along the x-axis is 5 meters and 20 meters along the y-axis. Here, if we want to describe the exact position of again this 30 meters long path and also added a direction sign between the starting and ending point of this path from south to the north. Here I would like to say that starting from the point A, if anyone crosses this way straightly to the point B through this direction sign, then he will definitely cross 10 meters of this way from south to the north or north to the south. Therefore, this 30 meters long way is 10 meters between the starting and ending point of this path from south to the north or north to the south. Since we have similarly added a direction with a length of 10 meters of the same path, so this 10 meters from south to the north is the example of vector quantity. Now we will discuss some properties of vector quantity. We know a vector quantity is different from a scalar quantity in terms of direction. That's why the vector quantity maintains some specific properties. First one is vectors have magnitude along with directions. A scalar quantity can be described only by magnitude, but vector quantities are described by both magnitude as well as directions. Second property is two vectors are equal if they have the same magnitude and the same direction. For example, the distance between A and B is 10 cm and the direction of the vector AB is to the west. Again, the distance between C and D is 10 cm and the direction of the vector CD is to the west also. Here we can say vectors AB and CD are two equal vectors. Third one is two or three homogeneous vectors can be added. Different type of vectors cannot be added. For example, two or more vectors of velocities can be added, but the vectors of velocity and acceleration or the vectors of velocity and force cannot be added. The fourth property of vectors is when two or more vectors are added, then the resultant vector is equal to the result of total action of the first two or more vectors. We know that any two vectors can be added as long as they are the same vector quantity. If two or more velocity vectors are added, then the result is a resultant velocity. If two or more force vectors are added, then the result is a resultant force. If two or more momentum vectors are added, then the result is a resultant momentum. Number 5. The vector product of two vectors is a vector quantity. That indicates the cross multiplication of two vector quantities gives a vector as a result. Number 6. The scalar product of two vectors is a scalar quantity. That indicates the dot multiplication of two vector quantities gives a scalar quantity as a result. Number 7. The direction of a vector is indicated by the proportion of the vector quantity and its magnitude. Number 8. Vector quantity obeys the rules of addition and distribution. Number 9. Vector quantity can be divided into components. Three components of vector quantities are x-axis, y-axis and z-axis. Because of these components, vector quantities can be 1, 2 or 3 dimensional. Number 10. The magnitude of the vector might be represented by absolute value sign around the vector symbol or just the letter without the bold face. Number 11. A vector quantity can be multiplied by another vector quantity but cannot divided by another vector quantity. Here in this slide I have added a figure of vector addition and subtraction. Here P and Q are two vectors and the addition result of these two vectors is A and B is the subtraction result between these two vectors. So the addition and subtraction of vectors usually follow these type of rules. Solution of mathematics related with this chapter. What is the magnitude of net force acting on the above figure? Here in this figure you all can see three forces along the west direction, east direction and north direction have been working, and we have to determine the exact magnitude of net force which is acting on this figure. Solution. Suppose the applied force along the west direction in the given figure Fw equals 20 Newton. According to the figure, the applied force along the east direction Fe equals 5 Newton. The applied force along the north direction Fn equals 20 Newton. Since we have to determine the magnitude of net force that is acting on the above figure, so at first we have to subtract the force along the east direction from the west direction, because the force along the east direction is working in the opposite of the force along the west direction. Therefore, the force along the west direction is also greater than the east direction. So, after subtracting, the total force along the west direction will be F1 equals Fw minus Fe equal to 20 minus 5 Newton equal to 15 Newton. After that, we will be able to determine the net force that is acting on the above figure. This force will be capital F, and capital F equal to root of F1 square plus Fn square equal to root of 15 square plus 20 square. equal to root of 225 plus 400 equal to root of 625, that is 25 Newton. So the magnitude of the net force that is acting on the given figure will be 25 Newton. So this is the finishing of my today's video. This video is the first video of my higher secondary channel, Advanced Science for Teenagers. Hope that you all will remain with my channels in the future. See you again in my next video of Advanced Science for Teenagers and Rabeya'S Knowledge Based Academy. Till then, Khuda Hafiz.